Hi, Stephanie. My name's Laura. Let me try and help you out with this. Please don't worry if the video of me goes a little bit odd. There's been a glitch there, but hopefully we can see you with your distance, rate, and time problem. So these are sometimes called DIRT problems because of the equation that we use to solve them. We know that distance covered is equal to how fast you're going multiplied by how long it takes to get there. So in this case, though, you've got something interesting going on. You've got two buses, and they're going in opposite directions from a single station. So they're traveling the same amount of time, and they're going in opposite directions, which is really useful to know because that means that the total amount that these guys are going to travel, I'm going to use a little t to show distance total, is going to equal to however fast that first bus is going. I'll call that rate 1, a little subscript of 1 so we keep track of it, times the amount of time we're given. And then you're going to add to it that second bus's travel speed times the amount of time it goes. And how come? Well, we were told they were going in opposite directions. So if I've got a little bus going this way and a little bus going that way from some center point, please forgive the bus drawing. We're not here for art today. We're here for our math, or maybe our physics. This is a type of kinematics too, right? Travel through space. So that total distance from the first bus is going to get added to that total distance from that second bus in order to find our final answer. And each of those distances are going to be determined by how fast each of the little vehicle buses were going. That's why we get to add it together. Okay? I recommend if you're working problems trying to figure out what you need to understand, drawing pictures can really help because it can show you how to set up the problem. Now let's look at what we know so we can figure out how to fill in this sort of equation framework that we built, adding together these two. Well, I'm noticing over here that we are told that one bus is 15 kilometers per hour faster than the second bus. And that's super useful because that means that that rate of that first bus can be rewritten in terms, meaning using the numbers associated with that second bus's rate. So that first rate is going to be the second rate plus 15 kilometers per hour. By the way, take the time to keep track of how they're measuring these speeds. Every now and then they try and trip you up by having one of them being minutes or in meters instead of kilometers and hours. But we match this time. That's very nice. We know that our distance total, let's go ahead and write that distance total because it's given right there, is going to be 1,050. And we know that we are going to travel for 6 hours. We can fill those in to our equation bit by bit now. So let's start filling in our equation so we can solve our distance. Oh, and what are we going to solve for? We're going to solve for one of the two rates and then use that to find by adding or subtracting that 15 kilometers an hour, the other rate. So let's see where we get to. We've got our distance total. I just said that we figured out that that is here, that 1,050, and it's in kilometers. And then that's going to equal to that first rate times time. And we know our time is 6 hours, added to that second rate times time, which again we know is 6 hours. We're almost there. We can't solve this yet because we need one variable for any equation that we're solving. We've got two. Aha! But remember, I was very happy back over here when we saw this. I can now write that first variable using the second variable, and then I will have just one unknown thing in my equation. Sorry, I'm trying to change back to black. Come on. There we go. 1,050 kilometers is going to equal to my rate 1 times 6 hours, but now instead of writing rate 1, I'm going to write rate 2 plus 15 kilometers per hour times 6 hours. And then I'm going to make sure I keep my plus, rate 2 also times 6 hours. And now I just have to solve through for rate 2. Okay, there's many ways that we can solve this. I will go ahead and just actually do the multiplication, right? We can go ahead and multiply this 6, multiply this 6 here and here, and I'll get 6 times whatever my second rate is, plus 6 times 15, I believe that would give me 90 kilometers per hour. Double check me on your calculator or in your head. All right, and plus our unknown rate 2, also multiplied by 6 hours. All right, and all this will still be equal to 1,050 kilometers. So what can we combine? Well, I can go ahead and add together my terms that involve my R variables. So let's do that. I can get 12 times my second rate plus 90 kilometers per hour is going to equal to 1,050. All right, subtract that 90 from both sides. Oh, and that's no longer kilometers per hour, is it? Because it was kilometers per hour multiplied by hours. So that's just kilometers now. That's great because that means that our units match and we can actually subtract them. That minus our 90 would give us 960 kilometers. Again, do double check me. And that will be equal to 12 times our second rate. All right, so let's double check. We now divide both sides by 12. 12. Right, those are 12 hours. That's good because I'm seeing kilometers per hour as my 960 divided by 12 as the units that we end up with. And we get 80 kilometers per hour would equal to my second rate. And that means that my first rate would equal to that 80 plus 15 kilometers per hour, or 95 kilometers per hour. Okay, that's looking really good. Now, you might think you're done because you have the answer. So yes, almost. You need to take one more moment and check that this was actually the right answer, that you didn't accidentally make a mistake partway through. So how do we check? Because we always want to check if we can. We plug these in to that equation, that distance total will equal to our first rate times the time plus our second rate times the time. And we find out, does this equal that 1,050? So our first rate we have now found to be 95 kilometers per hour. We know that we're multiplying by 6 hours. Our second rate is 80 kilometers per hour, also getting multiplied by 6 hours. And if that ends up actually equaling, when you do all the math through, 1,050, then you know for sure that your check has passed and that you really got the right answer. So what I want you to do is go ahead and work this through and then do that check and make sure I didn't make any typos partway through. Do I think it's good? Yeah, but we won't know until you work it through and check that final answer. Good luck with your work, Stephanie. I hope it goes well, and have a great rest of your day. Bye.